All right, so we have this conservation problem here. Each cart on the giant drop ride at Six Flags has a mass of 1,750 kilograms. The cart is at rest at the top of the giant drop, 65 meters above the ground. What is the velocity of the cart right before it reaches the ground once it is dropped? So if I were to take a look at what this looks like, we have the giant drop, right? There's the carts on top of it, right? And they're going to move this way. Okay, so if you remember, they're falling, right? So this would be our starting position, and here would be our end. Okay, if you've ever seen the giant drop, if you've been to Six Flags, right? It's just this massive tower. Okay, so what we know is, well, we have the mass right there. It's at rest at the top of the drop, 65 meters above the ground. We were looking for the velocity right before it reaches the ground. So that's basically at ground level. Okay, the height is 65 meters. It tells us the velocity at the top is 0, so I can fill that out with information I have. Well, this is right before it reaches the ground, so that's basically at ground level there. It's like a hair above the ground there. So what we're going to do is we're going to say the height at the bottom, in this case, is going to be 0 meters. Let's say meters per second in there. Okay, so this is all the information we have to begin with. There's a couple of things that we can actually end up doing is we can go ahead and just run some calculations pretty quick. And I'm going to go ahead and I'm going to start with my potential energies, and then I'll go to my velocities real fast. But the equation I'm going to end up using for potential energy is for gravitational. PE equals mgh. I'm going to plug my numbers in there. I know these are some large numbers, so it might get crammed a little bit. That's okay. 9.8 and the height of 65. Oh, look, I fit it. So our PE, in this case, I'm going to need to use my calculator. 1750 times 9.8 times 65 gets us our potential energy. It's a big number. 1,114,750. So 1,14750 joules. Okay, we can go ahead and, like I said, do our other one down here for the potential energy at the bottom when it reaches the ground. Okay, well, hopefully you know PE, again, equals mgh. Our mass is 1750. G is 9.8. And H is 0. So I don't even really need to plug this into my calculator, because anything times 0, I know the potential energy would have to be 0, right? Anytime there's a 0 in there, it just becomes 0. Okay, we can go over here and do the kinetic energy as well. Now, kinetic energy, if you remember, is Ke is 1/2 mv squared. I'm going to put in my 1/2, mass of 1,750, and then my velocity is 0 squared. But still, I should know this, and I don't even really need to use a calculator. 0 times anything in the world is going to get us a 0. So our kinetic energy at the top, when it's not moving, is 0. All right, that should kind of make sense. These two pieces should kind of make sense to you. If there's no height, there's no potential energy. If there's no velocity, there's no kinetic energy. Now what we're going to do is we're going to figure out our total mechanical energy here. And the way we do that, right, TME is equal to KE plus PE. Okay, well, what we can do is just add these together. KE is 0 plus our PE, which is 1,114,750 joules. We add those bad boys together and we get ourselves our total mechanical energy of the system, of 1114750 joules. Perfect. Okay, so that is the total mechanical energy. Now, what's nice about that, remember, what we've talked about is, in this case, we're ignoring friction. We're going to assume that all of this energy is going to be conserved because, well, energy is conserved. So whatever number we got there is the same exact number that we're going to write down here, because it is, in fact, the same value. Okay, perfect. Now, this part gets a little tricky because what we need to do is, obviously, we're looking to solve for the velocity. This is our end goal here. All right, this is our end goal. But before we can solve for velocity, we need to figure out how much kinetic energy there is. So I'm going to go ahead and use this same equation, the total mechanical energy equation, to solve for my kinetic energy. So TME is equal to KE plus PE. Okay, two ways to solve for kinetic energy. You can use the kinetic energy equation up here, or you can use this depending on what you know. And we know the total mechanical energy, and we also know the potential energy. So I'm going to plug these numbers in there. I get 1114750 is equal to KE plus 0, right? Because there is 0 potential energy here at the bottom, right? Remember, it loses all of its height. So we are left with our kinetic energy being equal to, well, our total mechanical energy in this case, 1114750. Perfect. Now we can solve for our velocity using the kinetic energy equation. That's what we're going to do right here in this box. And we're going to solve for our velocity using the kinetic energy equation. KE is equal to 1/2 mv squared. We know the kinetic energy. It is 1114750, which is equal to 1/2. And our mass was 1750. Oops, I wrote 1750 v squared. To start, we're going to solve these two. So we're going to simplify this right-hand side in the calculator. I get 1 divided by 2 times 1750, 875. So I can rewrite this. 1114750 is equal to 875 v squared. Now I need to get v squared by itself, so I'm going to divide by 875 on both sides. And I'm left with v squared equals, this goes in the calculator, 1114750 divided by 875 leaves me 1,274. Okay, but we're not done. We need to solve for v, not v squared. So I have to square root this. Okay, in my calculator, I'm going to go ahead and hit second square root, second answer. That's going to bring this answer right down in there. I hit enter, and I get a 35.69. So 35.69 meters per second. Whew, we fit it all in there. Looks good to me. Okay, so that is the final answer. But in order to do that, remember, we had to go through all of these steps to figure that piece out. Okay, so remember, total mechanical energy is conserved. In this case, our velocity was 0, so we had 0 kinetic energy. Our height is 0, so we had 0 potential energy at the bottom. We lost all of our height. We started with 65, we went to 0. we had no velocity and we gained velocity. So remember that our energy is going to be conserved. We gave away potential energy, and what we got was kinetic energy out of it. So we got some motion. All right. Hopefully that helps you guys with the conservation problems.